Okay, so in this video we're doing the logarithmic equation that's on the screen, and so to start in solving this equation, we notice that there's two terms that have a logarithm, and we would prefer to only have one term with a logarithm. So what I want to be able to do is use my properties of logarithms to combine the two logs, and before I can do that I need the two log terms to be on the same side of the equation. So I'm going to start by subtracting this term over to the left side of the equation. And now that I have both logarithmic terms on the same side, I can combine them, I can condense them down into a single logarithmic term, and since the two terms are subtracted inside of my single log, I'm going to divide 4x plus 9 over x minus 2. Okay, so that's much nicer. We have one single logarithm, and now once we get the equation to where it contains only one logarithm, we can transform the equation into an exponential equation. So what this equation translates into is that this number is the exponent 3. I'm going to put that exponent on my base, which we know to be 10. So I'm going to raise 10 to the third, and then that has to equal the expression that's inside of the log. So that step of transforming into exponential form is really just making use of the definition of what a logarithm is. And now we're off and running and just solving for x. So I'm going to eliminate the denominator, x plus 2. I'm sorry, that's a mistake. That should be x minus 2. I better correct that before I move on. It should be minus 2. I just miscopied. But that will make a difference, so I think we have it right now. We can eliminate the denominator. And then over on this right side, 10 cubed is 1,000, so I'm going to distribute that through the parentheses. That should be, well, let's see if I can get through the rest of this without making any more mistakes. 1000x minus 2000. And then from here we're just solving for x. So I'm going to subtract 4x from both sides. 996x. And then I'm going to add 2000, which would give me 2009. And then divide by 996. So that should give me, if I punch that into the calculator, or if I can maybe just do that in my head, it gives me about 2.02, and it's nice to have the decimal approximation because I want to make sure that this number isn't going to violate the domain of one of my original log terms. So if I go back to the original equation, that number should be okay, because if I was to put 2.02 in for x here, that would give me 0.02 inside of my logarithm, which is okay. And also if I plugged 2.02 in here, that's going to give me something that's positive, 4 times 2.02 plus 9, right? So we know we don't have to worry about that number being negative, so it looks like that number is okay for our answer, and that solves the equation.